here we go. Let's talk about this percent yield lab that's coming up. Review a few things also before we get going. The first thing we'll review is the idea of a limiting reactant. So we looked at this problem yesterday in your notes, and you can see it up there. There's a balanced equation. Always start with a balanced equation. Next, we're going to say which one of the reactants is going to produce a smaller product. So we start with 40.0 grams of nitrogen, run it through stoichiometry. Again, we're going from the periodic table, from the balanced equation to the periodic table, just like we did last week, and we get 48.6. Next up, we're going to go up here to 10 grams of hydrogen, do the same thing. So we're going grams to moles to moles to grams. We'll do that right here. Look at the periodic table, go to the valence equation, look at the periodic table, multiply and divide, and we can see that since 48.6 is smaller than 56.3, nitrogen is our winner, or I guess you'd say our loser, producing the most. That's the most you can make in this reaction. So what we're going to call this is our theoretical yield, which is important. We'll look at this and study this a lot the next few days, especially in the lab here, because this is the most we can make because it's limited by how much we have here. We can't make this much. We can add on to this just for a quick review of how much the excess is. And if we do that, we can simply say, well, if I know all 40 grams of nitrogen were used, how many grams of hydrogen were used? So again, we run through it quickly, only quickly because we've done this before, and we can see that we used a lot of the 10, but not all of the 10. So we take 10, subtract 8.63, and we're left with 1.37. So quick review on that, but really we're focusing on the theoretical. This is what we get in theory. So what we would get in the experiment, when we actually do the experiment and mass things out, versus what we get theoretical are two different things. But we want to compare the two to see how we did, or see what the reaction did. So this is the equation we use. We'll take your experimental divided by your theoretical and multiply by 100. So in the lab we'll do, well, let's talk about the last lab first. The last lab, we did the stoichiometry. You measured out a certain amount of lead nitrate, went from grams to moles to moles to moles to moles to grams, and you found that this should be, and that should be a PB right there. Sorry about that. So we went through there, again, that's a PB, and so when we go through that, we know how much we should have versus how much we have. After we went over here and we did the mass of our filter paper, then we said, okay, let's subtract the product, or excuse me, the product and the filter paper minus the filter paper, and we get something like, so this is, say, the mass and the filter paper. This is only the filter paper, so this is the actual compared to that. So that's pretty close. So let's do a quick percent yield. We do a percent yield, we get 0.31 divided by 0.35, 89% is our answer. So what we're going to do in the next time we meet here, hopefully, is we're going to look at about 2.3 grams of sodium hydrate carbonate, and we'll put to that, it says down here, 10 milliliters of HCl. What we really are going to look for is sodium chloride, because the carbon dioxide is going to leave in bubbles, as the water will leave with a little bit of evaporation on the watch glass. So we're really caring about the sodium chloride, which means we can predict how we should get theoretically. Right here, we can look at how much we should get by going from grams to moles to moles to grams, and we can predict how much we're supposed to get theoretically. When the reaction goes and we subtract everything and we get a experimental right here, we now have the two things we need to get our percent yield, which is great. So we'll simply run the experiment, follow the directions carefully, get a experimental mass, work our stoichiometry that we're so good at, assuming that this is our limiting reagent right here, because that's the only thing we took a mass on. So that's important to know. Some other important information we need to focus on always is make sure safety's first. Goggles and aprons. Tie the hair back if it's going to get in the flame, which we don't want it to. Hydrochloric acid will be in a bottle in the fume hood. Speaking of hydrochloric acid, make sure you pour it slowly into the watch glass, the evaporating dish. The evaporating dish is the thing that looks like this. You're going to want to put the watch glass down so it's curved down that way. You don't want to put it like this or it might jolt off. Last but not least, units on all calculations. I want to know, what is your compound? I want to know if it's grams or moles. All calculations and answers should have those things. So make sure you do that, and make sure that you get your numbers right and do your calculations. And thanks for watching, and be ready for this lab.